So EXTREVA ASE, as we know, it's the evolution of a legacy instrument, which is the AS350, right? So we're curious on how, the EXTREVA ASE compared to our competition, right? I mean, EXTREVA, in a sense, is either a pressurized liquid extraction, or also called by others as pressurized fluidic extraction system. We call it accelerated solvent extraction. In general, it's three terms used for essentially the same concept, right? A pressurized liquid to extract from a matrix. So first of all, Ed, I wonder how EXTREVA ASE differences from AS350. What are the key aspects you would say distinguish one instrument from the other?
Yeah, well, the main one, of course, is the fact that the EXTREVA ASE is PFAS ready. Right? So the earlier ACE models aren't PFAS free, so the components haven't been checked out. And that's a really important aspect on the EXTREVA ASE, that it's been completely checked out so that you can generate a PFAS free blank. That was one critical aspect. The other one is the dynamic pressurized gas extraction that was alluded to by Gopal earlier. And the fact that it reduces the time to extract the sample significantly, as well as reduces the solvent. And that has a big impact. Why? Because therefore you're not throwing more solvent in the environment, so the environmental footprint is smaller for the EXTREVA ASE, right? You're not generating as much solvent because you need less solvent with this system to extract your sample efficiently.
And when comparing to other vendors, like that also commercialize pressurized liquid extraction systems, like the EXTREVA ASE, what would be the advantages EXTREVA ASE have to offer?
Yeah, the biggest advantage is the integration of the extraction step and the evaporation step. It's all integrated together. Because once you separate them, as I mentioned earlier, you're going to have chances for contamination and also just increased time and labor dealing with it. And so having it as a almost true walk-away system, that's the important point, right? That you're going to set this up and you can do these samples, very easily and walk away from it without having to intervene is a critical step. Other types of instruments that are on the market, a lot of steps and modules, adds more cost and adds more labor.
Right, and if I recall from previous conversations, we're talking about 16 samples is typically the walk-away for EXTREVA ASE, with a throughput up to 96 samples.
Correct.
In terms of sample sizes, I mean, I know we touched this in the previous segment, but I'm curious in terms of what would be the sample cell sizes. Are we similar? Are we different compared to our competition?
Yeah, the sample cell sizes we have are 1 mil and 10 mils, and I believe up to 100 mil sample size, right? So we can cover a wider range than a lot of the competitor systems out there. They have, some of them are very small sample sizes they can handle. But in general, we handle, I think, the widest range of sample load. So the instrument's very adaptable to what you need to extract. And that's really important, again, because you might have EPA samples that require a certain weight because you can't deviate from that prescriptive method. But then you might want to go down to very low concentrations of, say, some textile or some other type of material that you're trying to extract. So having that variability and the ability to change the sample size is really important in the EXTREVA ASE that I think is different than our competition.
Yeah, that's a very good segue actually for you, Gopal. So I'm curious, right? So I asked this question to Ed before, but where do you see the future of EXTREVA ASE for PFAS analysis?
I mean, one thing you can do in future is to reduce the sample size. That will, especially for, like, I would say for tissue samples, because in tissue samples, especially with high fat percentage, I see a lot of metric interference from lipid, right? So it basically, you will see ion suppression in your analysis. So in that case, you need to basically use smaller sample size. Preferably, yes. As long as you can control your RSD percentage, definitely you can do that with EXTREVA ASE, reduce the sample size.
Excellent. So basically what I could gather is it's a very versatile instrument that it could be tuned depending on the needs, whether it's throughput, right, at the right detection limits, or whether I could also further reduce the sample size in order to increase even more the throughput, or increase the sample size in order to decrease my levels of detection and being able to see even to lower limits.
Correct.
Thank you, Gopal, for your insights.